Okay, so you should have the worksheet out that is titled Ratios and Proportions. I'm going to talk about what a ratio is, an extended ratio, and proportions, and how we can use these ideas to help us solve problems that involve triangles. And so let's first just talk about what a ratio. A ratio is a comparison of two quantities using division. And there are a few ways that we can express that. We can say A to B if we're using two different quantities. Of course, these would be numbers. You can use the A with a colon, B, and the one that we're going to use is the fraction. We're going to use the division. So this is the style we're going to use. All right, so here's an example. You got a baseball player's batting average is the ratio of the number of base hits to the number of at-bats, not including walks. Minnesota Twins Joe Mauer had the highest batting average in Major League Baseball in 2006. If he had 521 official at-bats and 181 hits, find his batting average. So in here it talks about how you find the batting average, which is stated batting average is the ratio of the number of hits to the number of at-bats. So that's what we need to think about when we write our ratio. We're going to put the number of hits over the number of at-bats. So how many times was he at the bat on the bottom? And however many hits he got goes on the top. And so if we keep reading, it says he had 521 at-bats, so that goes on the bottom, and 181 hits, that goes on the top. And you can put that into a calculator, or you can leave it as this fraction and reduce it if it does reduce, and it does not reduce. So you can leave it as a fraction, or you can give a decimal, which would be 0.347. So both of these are acceptable answers. All right, so if you want to pause the video and try the your turn problem, and then once you're done, you can unpause the video and see if you are correct. So in here, we want to know what is the student ratio, teacher ratio at the school. So you want to do your students, compare that to the number of teachers at the school. So student to teacher ratio. So the number of students would go on top, and the number of teachers would go on the bottom. And if you can reduce that, you would. And you should have gotten 13.94, yada, yada, yada. But we can't have parts of students, so we would say about 14 students per teacher, which is pretty small class sizes. All right. Hopefully you unpaused and you had the answer correct. Next, we're going to look at extended ratios. An extended ratio is basically used to compare three or more quantities. So extended ratios are used to compare three or more quantities. And we use this in triangles because there's three sides and there's three angles in a triangle. So that would just look like A to B to C. And you can see in this first example, it says the ratio of the measurements of angles in triangle ABC is 3 to 4 to 5. Find the measures of the angles. So because we're talking about angles, you have to think about a triangle's angles add up to equal 180 degrees. So what we're going to do is we're going to write an equation based on this extended ratio. So we can say 3x plus 4x plus 5x equals 180. And then all you have to do is solve this to find your solution. So 3x plus 4x plus 5x is 12x. Divide by 12, and you get x to be 15. But the question says that we need to find the measurements of all three angles. So my answer is not 15, but that's going to help me figure out the three angles. So we've got that 3x, 4x, and 5x. We would substitute this in for each of those x values. wherever you have an x. So 3 times 15 is 45. 3 times 4 is 60. And I'm sorry, 15. And then 5 times 15 is 75. So we're multiplying by 15. 3 times 15, 4 times 15, and 5 times 15. I'll tell you the wrong information here. So those are the 3 angles in that triangle. All right, so pause the video and try the your turn. Unpause the video and see if you got the correct answer. And I'll just work this out real quick so you can come back and check your answer. So we've got 3x plus 3x plus 8x equals 392, because that's what they told me the perimeter of the triangle is. And so this gives me 14x equals 392, divide by 14, so x would equal 28. We need to figure out the length of the longest side. So the longest side would be the 8x. So we would simply plug that in for 8 times 28. And you would get a length of 224 inches. So hopefully you unpause the video and you got the same answer. And if you missed it, then you can see how we got that answer. So those are your basic ratios, super simple, talked about them in previous math class. And now we're going to flip our paper over and we're going to look at proportions. You have also dealt with proportions in previous math classes. And so this should be a review. A proportion is basically 2 ratios set equal to each other. This is an equation that states 2 ratios are equal. And the way that we solve these, you just cross multiply. You would cross multiply. I would say divide, because you probably learned years past you'd cross multiply and divide, but sometimes you just cross multiply and then you got to solve for your x or whatever variable you have. So I don't want to just leave it as cross multiply and divide, because sometimes it's not that simple. All right, so this first example, we're going to cross multiply. I usually take the side that contains the variable and multiply those diagonals first, because I like my variable on the left side of my equation, but it does not matter which diagonal you start with. So I have 21 times x is 21x. Then I have 6 times 31.5, which is 189. And then we would divide to solve. So this one you would cross multiply and divide, but don't make a habit of that idea. So you get x to be 9. Because some of the other problems involve a little more work with multiplying and that sort of thing to solve your equation. You might have to add, subtract, and then divide. All right, pause the video and give the next 3 problems a try. Just cross multiply and then solve for your variable. And then you can unpause the video and see if you got these correct. And I'm going to work them out in case you missed them, and then you can see where you went wrong. All right, again, I'm going to start with my variable term. So negative 6x equals 4 times 11 is 44. Divide by negative 6. So x would be a fraction here or a decimal. I really don't care if you leave it as a reduced fraction or if you give me a decimal. Those are both correct answers. They mean the same thing. Some students would also give me a mixed number, such as negative 7 1/3. That would work as well. I'm not a big mixed number fan, though. I like the improper fractions or the decimals. All right, number 2. This one I would start with my variable term. Now here you're going to have to distribute, because what it really says is negative 4 times that 2y plus 5. So you have to distribute. My other diagonal is 7 times 6, which is 42. So this gives me negative 8y minus 10 equals 42. I'm going to add my 10. Negative 8y equals 52. And again, I get another fractional answer here, because when I divide by negative 8, I can reduce that. Did I do something wrong? I did. Sorry, you guys are probably looking at this going, Miss Messer, 4 times 5 is not 10. So I need to fix this. All right, easy peasy. I was working too fast. So I'm going to add 20, which is 62. All right, 62 divided by negative 8 is still a fraction, so I'll still write in that sense. And so you get negative 7.75 or negative 7 3/4. Again, I don't care how you leave your answer. And of course, you could have reduced that fraction and whatever that is reduced. 62, I'm cheating, I'm using my calculator. Because the rate I'm going, you may not want me to tell you what it would be, because I'd probably get it wrong. 23/2, negative 23/2. So again, fractional answers, decimal answers, I really don't care, whatever your preference is. All right, number 3, both of these have a variable, so I'm just going to start with either diagonal here. Notice I have them in parentheses because I need to distribute. Make sure I distribute correctly this time. I'm going to move my 7z over by subtracting it. So that gives me 2z minus 9 equals 7. Add my 9. You get 16. Oh, this one's a nice answer. You get 8. All right, so that's how you solve proportions. And like I said, that should be a review. Hopefully you paused the video and checked your work and you got them correct and you didn't make any silly mistakes like I did with my 4 times 5. Whoops. All right, then we can use proportions to make predictions. And basically, they're just saying you got a word problem, evaluate that word problem to figure out how many students own a car, for example, or how many wings on a butterfly are going to be tagged. All right, so Fernando conducted a survey of 50 students driving to school and found that 28 own their own cars. If 755 students drive to his school, predict the total number of students with their own cars. So I'm going to put the total of the surveyed students, which was 50, and out of those 50 kids, they found 28 actually had their own cars. And so I'm going to put on the top here, how many students drive to his school in real life is 755 out of the 50 he only ended up surveying. And so we need to figure out how many of them we're going to use this to predict based on what the data he collected to determine the number of students with their own cars. So we've got students with their own cars on the bottom and the students on the top. So again, I'm going to cross multiply. So I start with my variable term, gives me 50x. And then 28 times 750 is 21,140. Hope you have a calculator handy. Make sure you bring one to school too. Divide by 50, and so this is going to give me about 423 students own their own cars. And again, this is a prediction. It's not anything that is probably real, but he's just using the data that he collected. And of course, I rounded up from 422.8 if you put that in your calculator because you can't have 0.8 of a student. So we round up when we're talking about people. All right, so you can pause the video and try the your turn. In an experiment, students netted butterflies, recorded the number of tags on their wings, and then released them. The students netted 48 butterflies, and 3 of them had tagged wings. Predict the number of butterflies that would have tagged wings out of 100 netted. So 48 butterflies had 3 that were tagged. So out of 100 butterflies, how many would we expect to be tagged? So I set up my proportion. Cross multiply, I like to start with my variable side. So this would give me 48x equals 300. Divide by 48, and we get 6.25. You can't have a quarter of a butterfly, but you can say you have about 6, because it's a prediction anyways. So about 6 butterflies are going to have tagged wings out of the ones that they net. All right, so that should be a review of ratios and proportions. You will need this information to do your assignment this week. So make sure you understood. If you don't, make sure you ask me questions. Make sure you took all these good notes. You can pause, rewind, and rewatch if you need to. All right, and I will see you guys in the next video.